Hi, I'm Alex, and this is my Space App story. It is a story about string-based file input and output, or in programmer jargon, file I/O. But first, let me put on my hacker glasses. When putting in hours and hours of screen time, you might want to use a blue light filter like these, especially if you are like me and tend to develop a headache after more than 8 hours of hacking. Anywho, in this video, I hope to convey a coding idea that will help you in your own hackathon projects. This tutorial tidbit assumes you have installed a version of Python and a code writing environment. If not, visit python.org and you can get it for free. I use IDLE or idle available with the Python download. The shell looks like this, but there are so many others out there too. So what am I going to teach you in this video? In my view, staying organized is a huge part of writing code, especially when processing data. In this example, my hackathon team had found NO2 short-term air pollution data for 13 international cities. These data were organized into comma-separated values, also known as CSV files. Here's what these data look like in Excel. This is for the city Karachi. There's a timestamp and a level of NO2. Now my job was to combine these data as the dependent variable with other columns of independent variables to fit a statistical machine learning model to try to explain air pollution drops during the COVID-19 pandemic. While there are many ways to do this, I chose to use the Pandas package in Python. Pandas is a toolkit for use with the Python language. Pandas is usually downloaded via a command line interface in Python itself. Search the keyword install to learn how to do this for your particular operating system and code writing environment. It might use the syntax pip or pip. The function I chose to use within Pandas is called read_CSV. Here is the read_CSV documentation, which can be real useful to understand any functions, inputs / parameters, and outputs / returns. The purpose of the read CSV function is to open this .csv files and load whatever table it finds into a Pandas data structure called a data frame. The NO2 files my team found follow a naming convention. So I use this string pattern in my data access loop. First, I built a string array of all 13 city names. Then, I initiate a for loop and use the iterator nn to stand for each city name. In other words, the first time through the loop, nn equals the string Beijing, and I can work on the Beijing_no2.csv. The next time through the loop, nn equals the string Berlin, and I can do the same work on Berlin_no2.csv, all the way until the last iteration and nn equals Madrid. Within the loop, I use the Python function .format, like this, to name the files. Also, and this is very important, within the loop, I use the print member function to report my progress to the screen. This is because the processing may involve searching or sorting these data, which could take a real long time. I want to be sure I know whether my code is running or hanging up somewhere, and printing the code every so often helps me to troubleshoot. Running that script produces the following. Bingo! The loop is done. Otherwise, your code ends up looking like this. Notice how I call read_CSV many times in a row for each city instead of using a loop. Without the loop, it becomes very difficult to make small changes to code consistent. One of my hackathon partners actually inspired me to create this tutorial video because they used multiple files for each city when fitting the statistical machine learning model. While a perfectly valid solution, this made it difficult for us to edit the code together and make small changes like retitling these plots we made of the model fit. I needed to go every file one by one and make the change manually, which is fine, just not the best for conserving time and can be frustrating when there are multiple rounds of changes. In conclusion, using a string array and iterator in a loop for file I/O can help save time. You can process your data in large batches without having to write too much repetitive code. I worked in Python pandas to show you in practice, but this theory can be used in any language, R, C, MATLAB, Java, whatever you want. Finally, I will remove my hacker glasses and give you a heartfelt good luck for the hackathon. I hope you have fun and, more importantly, learn some new ways to use computer code along the way. Thank you.